Thank you very much for coming out and checking out our talk. My name is Joe Granja, and I'm one of the core committers on the Spring Security team. I've been working on mainly focused on the OAuth client support since we introduced it in 5.0, which is a rewrite of the existing Spring Security OAuth project. We call it the legacy project, which is in maintenance mode. So it's been a huge undertaking. In 5.2, we just released 2 weeks ago, I think, which is a huge milestone. I'm going to get into those details in a little bit. But co-presenting with Stephen.
Hey everyone, my name is Stephen Doxy. I'm a software engineer and independent consultant through my company, Simple Step Solutions. And I'm not on the Spring Security core team, but I am a contributor, and I've been using Spring Security for about 10 years now. And several years ago, my clients began adopting newer architectures with single-page applications and microservices, and I found myself needing to deep dive into modern security protocols like OpenID Connect and OAuth2 to better guide them on their journeys. So I found with each successive release of Spring Security 5 that job is getting easier and easier for me. So this is my first time speaking at Spring 1, and I'm really honored to do so, especially with someone like Joe.
Well, hey, thanks for coming out. Thanks for co-presenting with me. Really appreciate it. First thing I want to do before I start is I want to apologize. I'm recovering from a cold, so I might be coughing away, but don't worry, it's not contagious. It's the tail end, but this cough's not going away. I want to gauge the audience first before I kind of get into the talk. Is if you could participate and raise up your hands. I just want to see where everyone's at here. Who has experience working with OAuth and OpenID Connect? Please raise up your hands. Perfect. Now, who's using the new OAuth support in Spring Security 5 and so forth? Please raise your hands. Right on. And who's using legacy OAuth, Spring Security OAuth 2. whatever? Please raise your hands. Okay, and out of the ones that are using the new OAuth support, who has migrated from the old to the new? Okay, not much. Oh no. Okay, we gotta definitely get you guys going. But 5.2 is a huge milestone in this whole rewrite, right? We're essentially at feature parity with client and resource server. I mean, 95% on the client, but fully 100% on the resource server. This is the time to migrate. Keep an eye out. Over the next month, we're going to put together a migration guide for old to new and how to migrate, right? There's an issue there. I can't remember the issue number, but keep track of that. We're going to put together something so it's going to be easy for you to migrate. And I highly advise you to migrate because, once again, legacy OAuth, maintenance mode, right? We're only doing bug fixes and patch minor enhancements. And the new OAuth support has got a lot more features, right? On top of OpenID Connect specific features, Jose specific features, which legacy OAuth never had. There's no OpenID Connect support there whatsoever. So you get more bang for your buck on the new side. So definitely migrate. Okay. So I got a couple of slides here. We are literally just going to do a demo and some code walkthroughs securing a microservice architecture. That is the goal. But before we get into that, I want to just, one last thing. If you have any questions during the talk, please save it for the end because we got a lot to go through. We are going to save time for the end, but let's save it for the end. I appreciate that, okay? Let's do a quick high level of the standards that have been implemented within Spring Security. I mean, it all starts with OAuth2 authorization framework, right? Now, OAuth2, the whole goal of OAuth2 is being able to, for an end user, to authorize an OAuth application or an OAuth client to access its protected resources on behalf of the user. That's in certain grants, like authorization code, but also the client can act on its own behalf, like the client credentials, right? But the whole idea is OAuth client application or an OAuth client accessing protected resources, a limited set of protected resources with a limited lifespan, as in access token expires at a certain moment in time, right? And there's a lot more involved. There's a lot of authorization grants available, extension grants. I mean, we've got the authorization code, client credentials, implicit, and resource owner password credentials grant, which is new in 5.2, by the way. Wanted to point that out. We just introduced support for that in 5.2. But it's all about authorization, right? OAuth2. It has nothing to do with authentication. That's where OpenID Connect comes in. So OpenID Connect, it's basically an extension on top of OAuth2 that provides authentication, and it introduces the ID token, right? And the ID token comes back on the token endpoint, at least on the authorization code grant flow, and the client relies on the ID token to ultimately authenticate the user. And that's why the client is also called the relying party, RP, right? Because it relies on the ID token and ultimately the assertions or the claims in the ID token to authenticate the user. Because those assertions describe or they're assertions about the authenticated user at the provider at that moment in time, right? So that's why it's called the relying party. So that's OpenID Connect. Then we have optional specifications in the OpenID Connect set of specifications, OpenID Connect Discovery. So OpenID Connect Discovery, if a provider, an OpenID Connect provider supports this, it exposes an endpoint that provides configuration metadata of the provider, as in this is where I can find the authorization endpoint, the token endpoint, the JWK set endpoint, the authorization grant supported, the scope supported, and so forth. So Steven's actually going to demo that part right when we jump into the demo there. And then obviously we got JWT and access token format, a self-contained access token format compared to an opaque token format. And once again, 5.2 resource server introduced opaque token support. So check that out if you've been waiting for that. But yeah, JWT is a self-contained token. You got a header there. In there, you typically get the algorithm that was used to sign the token or the algorithm that was used to encrypt the token. But as far as the signature goes, I mean, that's JSON web signatures. So the Jose framework, you got obviously JWT, JWS, JSON web signature, JWE, JSON web encryption, because a token could be signed and then encrypted. But you got to obviously have the ability to verify the signature, and that's where JWK comes in, JSON web key, right? And once again, Steven's going to demonstrate that, the JWK endpoint where it exposes the public key that the provider used to sign the token, and ultimately where the client or the resource server fetches the public key to verify the signature on the JWS, right? So that's very quick, high level. I'm not going to get into too much more details because we want to jump into code, right? That's why we're here, right? This is our application, right? So instead of a simple application, we put together more of a real-world application because, yeah, it's easy to have a simple, OpenID Connect application, but users are always asking, how do we piece things together? What authorization grants do we use for a specific client in a specific flow? Right, so what we're going to demonstrate here is, so we got 3 microservices, 3 resource servers, and then a UI app where all requests come through, and the UI app just fans requests out to the backend resource servers, and then other resource servers we'll call other backstream backend resource servers, like in the case microservice B to C. Right, so we're gonna set up OpenID Connect authentication on the UI app. And then we're going to set up another client there for just standard OAuth2 authorization code that's going to pass the access, obtain the access token and pass it to microservice A and microservice B. And then for the final part of the presentation or the demo, we're going to set up a client on microservice B to perform the client credentials grant to obtain the token and call microservice C. And we're going to explain why we would use authorization code grant versus client credentials as we go through the demo. Okay? So let's jump to that. Steven's going to take over for this next part here and set up OpenID Connect authentication. All right.
Awesome. Thanks so much, Joe.
For sure.
All right. So let me just show you the app that we're working with right here. So here we have our UI app. We have our different microservices running, A, B, and C. We have Key Cloak running, but we're not actually doing any authentication or authorization yet. Right now, this is our UI app. We end up demonstrating some different flows, common flows that you might encounter in your organizations. Just a UI app calling a single resource server, an app calling 2 different resource servers, token relay, token exchange. You can play with these later on, and the source is online. But the one that we're going to be digging into today is client credentials. And just like Joe was saying in that architecture diagram, the UI app's going to call service A and service B, but then service B is going to go and use client credentials to call service C at the end. So this is a little outline of what we're going to be doing. So we have our flow sequence that Joe described. of what we're going to be doing. And we have 3 different sections because there's 3 different places where these tokens are going to be passed back and forth. So UI app to service A, UI app to service B, and service B to service C. Is that too small for you guys? I think I might be able to make that a little bit bigger. Is that better? Okay, so yeah, so we have information here that we're going to be filling in as we're going along as those tokens start flowing. There's no business domain or anything in this app. There's no databases. What we're really wanting to zero in on is the flow of tokens and how all that works, and leave the business details for whatever happens to be going on in your organization. So before we get into any of the authorization, though, let's first authenticate our application with an authorization server. So what we want to do is first go to our UI application right here. And we're going to go to our dependencies as a starting point. So let me just open that up so you can see that. So here you can see that we have a starter for security and a starter for OAuth2 client. So that's going to add the jars that we need for auto configuration and Spring Boot to take place to detect our different client registrations that we have in our application YAML or application properties. So those are already in there, but the reason that nothing's really going on is we don't have, we've actually, in here we've excluded the auto configuration just for showing things when they're starting up, because otherwise auto configuration would be kicking in. We didn't want that to happen yet, so we're just going to remove that. Sorry, that's a bit small, but we'll zoom in here for the application YAML, because next we're actually going to want to add our configuration in here. So we're going to do, we're doing authentication. So this is with OpenID Connect. The main idea is that we want to have, we want to set up our client to verify the identity of the end user based on the authentication that's happening at the authorization server. So I'm just going to add in a section here for, okay. So I'll just explain this. There's a lot of stuff there. It's going to get simpler, I promise, in a bit. But so what we have is Spring Security OAuth2 Client. That's where we put all our different client registrations, as well as define our different providers that we're going to be using. So our provider here is going to be Key Cloak. We need to tell our client about our provider because that's what the client's going to be interacting with. We're a relying party on that provider, Key Cloak. And to set up Key Cloak, we need to tell the client, okay, you're going to want to go to this authorization URI. You're going to want to go to this place for your token URI, user info, and this is where you're going to find your keys at the JWK set URI. Now in this we could put multiple providers here, but here in this registration section, we're going to be putting in different client registrations. So the first one is we're working on a single client registration. This is Login Client. Now this is an arbitrary name. It's just an identifier for our client registration, and this is the identifier that you'd be using to look up in your client registration repository to grab hold of that client registration. Now the key thing that makes this OpenID Connect is in our scope section here when we're defining our client, there's an OpenID scope that we're requesting. That tells the OpenID Connect provider or the authorization server that has OpenID Connect enabled that we want to get not only our authorization or our access token and optionally a refresh token, but we also want to get that ID token that Joe was talking about that we can use for claims to create our authentication on our UI application. So in here we've linked up our client to our specific provider, and later on we're going to be adding another client as well. But right now we've got one client ID. This is Login Client. This is the client ID that's registered at the authorization server. It doesn't necessarily have to match what's happening on your client registration ID up here. This is a different thing, but we've made them the same here. Now you will notice that there's no client secret. Often we have a client secret that we're working with. Now client secret is what you would use to, client ID and client secret together are kind of those are the the basic credentials that you'd be using to authenticate yourself with the authorization server, but we don't have that in this case. What we're wanting to demonstrate here is a public client. Now, why would we have a public client for a web application? Usually a web application is on a secure server. I just want to give you an example of something that I've encountered with one of my clients. We had an old Swing application, desktop, JavaFX or something, where the client is actually living on the end user's machine. So if you're wanting to configure that, you obviously can't keep the client secret in that configuration on that person's machine, or that client secret could get exposed. So what we're leveraging is a new feature in Spring 5.2 that I got to contribute to for adding PKCE support, which is Proof Key for Code Exchange, or PKCE. There's a lot of different names for it, but it's basically an extension on OAuth2 that allows, that mitigates attacks against authorization code grant interception. So what happens with the authorization code flow is you call the authorization endpoint, you get back an authorization code, and then you take that code and then back channel, you'd use your client ID and client secret normally to get the actual token afterwards. But in this case, since we don't have a client secret, anyone could see that public client ID and steal your code, and then you could have different problems. So PKCE helps deal with that situation, and we've added that into Spring Security 5.2. So we're just wanting to demonstrate that here in this web app, even though you'd probably be doing this in a different scenario, maybe on a desktop type application that has like some web component to it as well. And the other thing is we're going to be adding another client in a second that's going to be handling the authorization. But that one, we're going to use a client ID and a client secret. Usually you'd have on a particular client, you'd probably be using the same, they either both be public or both be confidential. So that's just explaining why they might be mixed in this, because we want to just demonstrate the different ways that we're going to be able to work with this. So the way that PKCE or PKCE is activated is by the absence of the client secret and by adding the client authentication method of none, which is normally basic. Here we also have the authorization grant type, authorization code, and the redirect URI, where we're going to be going to collect that authorization code grant when it comes back from the authorization server. Okay, so let's just save this. And what we're going to do is just restart our UI application. And then we'll come back to our app. And hopefully what we would see is we shouldn't be able to get in here, right? Because we don't have any first or last name or anything. We want the application to redirect us over to the authorization server. So I'm going to refresh this. And there we go. We're being sent over to the authorization server, over to Key Cloak, where we can enter our credentials and authenticate over there. So user1 is our username and password. Okay, so now it's going to ask me, the end user, do I grant access to this login client to have access to these certain scopes, which are profile and email. Those are the two other ones other than OpenID that we requested. And I'll say, yes, we do. Okay, so now we've been redirected back over to our application, and already now we have our first and last name being populated. We're authenticated. We have a session. We can drill into our session here and see that because of the ID token that came back in the user endpoint, we have an enhanced authentication with different ID token claims. The subject identifier is identifies the user who's been authenticated at a certain issuer. The issuer is our Key Cloak Authorization Server URL. We've got our audience, who the token was for, and a bunch of other claims that we're just not even showing here as well. The other thing we want to look at here is the client registration section. This is kind of a view, a debug introspection view into what's happening of our client registration repo. So we have just one login, or one client right now, login client with the authorization code grant, and also we can see now that it's been authorized with the following scopes. We can drill in further to see some of the tokens that were given. So we have an access token, an ID token, and a refresh token. So what I'd like to do is just actually just take this ID token that we were given, and let's go to jot.io, where we can go and look and see what's inside there. So this is our JOT, and it's just a base 64 encoded string with little JSON strings with little dots separating the sections. So the first red section here is the header. We can see that the algorithm's RS-256. That's what's been used to sign this JOT. And there's a KID, a KID, that is the Authorization Servers JSON web key. This is the identifier of that key that we are that we're using. And here's all the different payload data. There's lots of different things in there. Let me just open up another section here for comparison purposes. So this is the discovery endpoint that Joe was talking about. So if you take the issuer URL from the beginning and then tack on .well-known OpenID configuration, many OpenID Connect providers will have these implemented where a client or resource server can discover a whole bunch of things about the authorization server to configure itself. So authorization endpoint, token endpoint, user info endpoint, some of the ones that we were having to configure manually. We also have this JWKS URI where all the keys that it uses to sign are published. So here there's an array of keys, but there's only one currently. There could be other ones, but we can see here that we have the KID, the ID of this key, B0R, which you can see here is the same as the ID that was used here to sign this token. This last section is the JSON web signature, which is basically the two prior sections being signed with RS-256. Okay, so one other thing we can do with this discovery endpoint is we can make our configuration just a lot simpler. So what I'm going to do is just close that down. Here we are, and what I'm going to do is instead of putting all these things in manually, we can type in issuer here, which is the just point to our issuer and get rid of all these other pieces. And since we are using issuer and discovery, we can actually get rid of this because the authorization grant type is defaulted, the redirect URI is defaulted. So we've really tightened up our configuration here. Let's try restarting the UI app and see if everything works as it did before. So I'm just going to close down all these windows. We'll just open up a new one here. Okay, so we're still getting redirected back over to our authorization server just like before, but with a simpler configuration. We've already given consent to those other scopes, so we won't be asked about that anymore. We'll just get redirected back in, and our session state and everything is back up just like it was before with very little configuration at all. So just to recap here, we have just added our we haven't done authorization yet. We've only been focusing on authentication, and we have basically allowed authentication to happen using OpenID Connect at the UI app. Joe's going to now show us how we can secure our communications with Microservice A and Microservice B with OAuth2.
Right on. Thank you. Let me get some water here first. Okay, so now that we have authentication, next is we're going to secure our resource servers. We're going to set up authorization, and we're going to set up a client on UI app to ultimately obtain a token and pass that token and call Microservice A and Microservice B. So let's set that up. The first step is we're going to secure Microservice A. So we're going to stand up, our resource server is already stood up. It's just not configured. It's completely open. So we're going to protect that right now. Let's do that first. Okay, where are we here? Okay, so we'll go to Microservice A. Now, same thing here. We've excluded the auto configurations. So I'm going to just remove that. And just like in the UI app, just like in any Spring Boot application, really, first thing is we're going to include our dependencies, right? So the dependency here is the OAuth2 resource server starter. Everyone can see that, right? Here, I'll just maximize that. So there's a starter. So that basically includes all the dependencies required for a resource server. And the next thing is we're going to add our properties. So let's go to our properties on microservice A here. Make that bigger. And then there we have it, right? So base property path, Spring Security OAuth2 resource server. And then we have JWT, because Key Cloak is minting JWTs. So we're going to configure our resource server to accept JWTs and verify JWTs. Again, I believe it's opaque, if I recall correctly. In 5.2, we introduced support for the introspection endpoint. So if your provider is minting opaque tokens, then you would configure resource server opaque and so forth, right? Check out that for sure. That's in 5.2. The good news is as you can see here, we've configured a JWK set URI, but also with resource servers support the OpenID Connect discovery endpoint as well. So, to be consistent and make things simple, even though it doesn't really reduce any lines of code, but in the future we very well might add extra properties in JWT. So, discovering via the issuer endpoint, it's pretty convenient, right? Because ultimately the resource server or the client can configure itself, right? And ultimately reduce your configuration. So that's it, right? So we included the dependency, we added the properties. Let's make sure our resource server is actually protected. Okay, so I'm going to restart it. And then I'll just go directly to the endpoint, to the service. And I believe that's 9,000, and it's service A. All right, so we go there. As you can see here, 401, right? Because we're not passing an access token, right? So we definitely know we're secure on microservice A, right? Now, microservice B, we got to secure microservice B as well. But I'm not going to bother. Doing that same steps because it's literally the same steps. So what I'm going to do a force checkout. So we could just get to that point, and I'm just going to ensure that we actually are at that point. I'm going to restart microservice B, and I'm expecting to get a 401 there as well. But let's just double check before we proceed to setting up the client on the UI app to call the two services. Let's jump here. So it's microservice B, 9001 port, and there we go, right? So now microservice A, microservice B, completely secure. Now let's jump to the client, right? Let's configure the client that's going to call those two services. So we'll go to the UI app here. We're going to configure our client registration. Our dependency is already included, so we're good on that end. So let's configure another client registration here. It's going to perform the authorization code grant. And there we have client AB. You'll notice when you look at this repo, you'll notice the naming conventions. We got microservice A, microservice B, microservice C. And then we have, for all the different flows, we have like client A, which calls microservice A, client AB, which calls microservice AB. And then you notice the scopes here, authority A, authority B. Microservice A authorizes and only accepts requests that have that particular authority A or scope, and microservice B authorizes an authority B, right? So we've kind of given these naming conventions so it's really easy to follow the different clients and the scopes and the services. So keep that in mind when you're checking it out on your own. And you notice here this is a confidential client, right? Got a client secret, so this is used to authenticate the client at the token endpoint. And then the flow ABC, that's basically our controller, our main controller handler that we're hitting from the main client credentials flow, right? So we want to redirect to that endpoint and that's exactly the client we want to use to call the two services, right? Okay, so we got our client registration. Now this is pretty much configured, but now ultimately we have to authorize this client, and then we have to use the authorized client and its associated token to pass the token to the two services, right? So the next thing we got to do is configure our HTTP clients that's going to actually set the authorization header and pass the token. But first, obviously, we got to authorize, right? So the next step we're going to do is we're going to set up our HTTP client. In this case, we're using the client credentials, or sorry, web clients. So let's go here, and I'm going to expand. Actually, you know what I'm going to do? I'm going to close everything down so it's nice and clean. And then I'm going to expand this, and then I'll make this bigger. Okay, so let's add that. Now, for those of you that are familiar with using OAuth2 client in 5.1, this is what you're going to be familiar with. This is how you configure a web client with OAuth2 client integration, right? So here we have the servlet OAuth2 authorize exchange filter function. So this is an exchange filter function that you could add to web client as a filter within its filter chain, right? So it could do some request pre-processing, which ultimately is what we got to do, right? We got to ultimately get an access token and set the authorization header. But first we got to authorize the client if it's not authorized, right? But this is simply this servlet authorize exchange filter function. That's what it does. It performs authorizations of clients, and if the client is already authorized, it just sets the authorization header. But this is essentially how you could configure it, right? You set up the exchange filter function, you pass in the client registration repository, which is repository of all the client registrations. In this particular instance, we have two, right? The login client and the client AB, and then the authorized client repository. And for those of you that are not familiar with the authorized client repository, I mean, this is ultimately where when clients are authorized, they get saved to this repository, right? And it's a representation of an OAuth2 authorized client instance, right? And this essentially is just an association of the end user, which represents the principal name, typically, you know, the current authentication within the security context. So this is essentially authentication.getName. That's what the principal name is. The end user that authorized that client registration, and the end result of that flow, successful flow, is an access token and optionally a refresh token depending on the grant, and also depending if the client is even configured on the provider to return a token. There's a couple of dependencies on the refresh token. So that's the, you know, ultimately the authorized client is what you need, right, to get the access token to make your protected resource call. So this is you know, the standard configuration 5.1, but what I want to show you that's new in 5.2 is a couple of really big features, and I want to kind of go over this a bit with you, so you could see the motivation behind this and what you could use this with. So we had this issue logged a while back where a user couldn't use web clients, right? Because ultimately they had REST template in their enterprise app and it was used everywhere. Like that would be a huge refactoring exercise. They did not want to do that. They just want an access token, right? And then use HTTP client of their choosing, right? So we did that because all the client credentials and refresh token grants were baked into the exchange filter function, right? So you can use that, right? That's meant for well, whatever API takes an exchange filter function, which web client is one of them. REST template that doesn't work with a REST template. You just can't reuse that. So users actually wanted more reusability around that. So what we did is it was a big refactoring exercise. We took out all that, a lot of the logic out of the exchange filter function and brought it into implementations of an authorized client provider, right? So we have these two new core interfaces, authorized client manager that's associated with an authorized client provider. And from a high level, the authorized client manager is solely responsible for looking up an authorized client, saving an authorized client, authorizing a client by delegating to an authorized client provider. As you can see here, we have this convenience builder, and what's happening here is enabling authorization code, refresh token, client credentials. And when it does the build, it's ultimately just building a composite of three implementations of an authorized client provider. An authorized client provider, the sole purpose of that is to realize an authorization grant, right? I mean, this particular one, the authorization code, it just really just throws an exception, and the filters handle that. But the refresh token, the client credentials, it's basically an implementation of the call to the token endpoint to get an access token. So these are fully reusable. There's no dependencies to HTTP servlet request or Webflux. So these authorized client provider instances can be reused pretty much in any stack. However, the authorized client manager that's associated to an authorized client provider, there's a couple of different implementations we have. We have servlet-based one and a Webflux one. But if a user wanted to use WebSockets or even RSocket, you would implement an authorized client manager for that particular stack and reuse the authorized client provider. So high reusability here. And like I mentioned, the default authorized client manager in this case for the servlet-based one, I'm building my provider and then I'm setting the association, because ultimately the authorized client manager here, we got one interface method here, takes in an OAuth2 authorized request. So let's let's talk about authorizing a client initially, right? So I would, as a user, right, of REST template, for example, I'm using REST template. I want to get an access token. All I got to do is I got to make sure that my client registration ID in this particular use case that I'm demonstrating is client AB, right, and principal is populated with basically the current authentication within security context. I pass that in, and ultimately what's going to come back is an authorized client, right? And now I have access to an access token, and now I could use that to set the authorization header, whether it's REST template or find client or straight up Apache HTTP client, right? So this is really, really big, really excited about this one. So I just wanted to do a quick high level of that one. As you can see here, I'm defining the authorized client manager here, building the authorized client provider composite, setting out the manager, and exposing it as being. So now I could inject this anywhere in my code and use it with any HTTP client that I'm using in that particular piece of code that I'm working with. The good news is you don't need all this verbose. Well, it's not too verbose. I mean, if you want to fine-tune your authorized client manager, then you would go ahead and do that. But at the same time, if you want to just stick with your existing configuration, because that's what you have, you could do that too. Because ultimately what happens here is it's just building a default authorized client manager with all grant support. So you don't have to change your existing code if that's what you have. But the authorized client manager is now used in the exchange filter functions and in a couple of other places. Those are the central interfaces to authorize a client ultimately. Okay, so that's 5.2. So we've set up our web client with OAuth2 client extensions. Now I'm going to jump to the controller and ultimately use this web client to authorize. Okay, that's not the one. Yes, that's the one I want. Let's jump to this one here. Okay, so I'll make this bigger here. Okay, so there's a couple of different ways you could resolve an authorized client. Ultimately, a couple of ways to obtain one. So we have this annotation, registered OAuth2 authorized client. Handler method arguments resolver web MVC that ultimately authorize an OAuth2 authorized client. And there I'm specifying the client registration ID, right? Client AB. And when I hit this endpoint, which is the main handler method endpoint, when we're on the UI app and we're clicking the client credentials flow, it hits here. But obviously the first time I hit this, it's not going to be able to resolve the authorized client because I haven't authorized it. So what happens is authorization code kicks in, right? The flow, the OAuth dances, some people call it. And then I go through the flow, I authorize that client with the scopes, and then it comes back to the redirect URI, which is this endpoint, as you saw in my client registration, and then it resolves it. Now I have an authorized client, and the access token that was just granted, and now I could use that, right, to pass into, to ultimately set an authorization header. And Steven's going to show the other way how to obtain an authorized client without having to use this annotation. But I'll save that. I'll save that for him. But let's look at the code here. Now here's the web client call. The key thing here, really, I mean, everything's similar. Everything's the same here for any web client call. The only difference is attributes here. This OAuth2 authorized client. So that's a static. Excuse me. That's a static method within the exchange filter function. And ultimately, what it does is it sets the authorized client in a well-known request attribute, right? And the exchange filter function, when it does its thing, it looks up the authorized client and then ultimately gets the access token, sets the authorization header, right? So right now, we should be at a point where, okay, we've secured microservice A and B as the first step. Now we've configured all our OAuth2 client for client A, B, and all the different points, which is client registration. I mean, we did our dependencies, we configured our web client, and now we just got to use our web client, which is right here. So let's check this out. Let's see. We should be able to see some data now, or token attributes in the UI app. So I'm going to restart the UI app here. And I don't recall if oh yeah, no, you know what? I did start microservice A and B, so we're good there, because we did actually try to hit those endpoints. I like to start fresh just to make sure, you know, there's no caching or anything, even though we're in incognito, but you know, I like to play it safe. Oh, one more. Make this bigger too. Let's authenticate right now. Okay, so here we are. I'm going to make this bigger too as well. Okay, there we go, right? Just like I said, when we hit that endpoint and we have that annotation, registered authorized client, it basically throws an exception, filters kick in, redirect to the authorization endpoint, and now we're getting the consent screen. You know, do we authorize this specific client or this OAuth application to access these limited resources, authority A and authority B? Yes, we'll click on yes, and come back here, and there we go, right? So now we could see, you know, we have, you know, the first leg of our securing our application done, right? We have a client that's obtaining an access token and calling microservice A and microservice B. We could see the JTI, the JSON Web Token Identifier. It's the same, right, for the two. And then we could also see the authorities that were authorized, or the scopes. And then the subject, right? The subject is the same. That's user one, the person that was authenticated, because I own the token. The client is only acting on my behalf, right? And that's my unique identifier at the provider. And there we have it. So this is where we're at now. So we have, we've protected microservice A and B. UI app is now calling microservice A, microservice B. Now Steven is going to jump in, and now he's going to protect microservice C and so forth. So yeah, go for it.
Thanks, Joe.
Right on.
All right. So as you could see there before, we have no JOT information in this final leg of our journey, service B to service C. We're not protecting microservice C at all quite yet. So if we come back over here, we're just going to, similarly to what we did before, we're just going to jump ahead to secure microservice C and just make sure that that gets secured. And then we're just going to refresh that one as well. Restart that. Let's just make sure that that one is locked down. Okay, great. So we got our 401 there. That's great. So now what we need to do is we need to take microservice B for this final leg of the journey and make that not only a resource server like it currently is, but also a client, because it's also receiving tokens and retrieving tokens in order to send them to downstream services. So what we're going to do is go directly to just a second here. We're going to go to the Gradle file to just see the different dependencies that we have. Now, we're not looking at microservice C, sorry. We want to be securing microservice B at this point. And okay, so I'm just going to zoom in here so you can see these dependencies. So the other ones we were just adding security starters and OAuth2 resource server starters. But in this case, we're also going to add the OAuth2 client starter as well. So what we're going to do is now go and configure the client registration for that other, for the client portion of this. So we're going to close this down and go over to our application YAML. Zoom in here. So here you can see that we already have our resource server configured, but we want to now add in our client configuration. So here we are, client credentials. Okay, so just as we did before for the other client, we've got a registration section and a provider section. Key Cloak's the same as it was using Discovery. And this time we're going to call give our client registration ID the ID of client C, because we're wanting to talk to client C and we want to have authority C. Because microservice C is going to be authorizing on authority C. So we'll link up our provider, our client ID is client C, secret. But the one thing that's different here is we're using the authorization grant type client credentials. So why would we be using client credentials here? Now, just take a e-commerce site, for example. You've got a shopping cart. Now, those would need those would often need user information. So that's why you'd use more of a user flow where the subject would be an actual user, like user 1 or something, because you want to know whose shopping cart this is, and you want to authorize on that information. But say you have like a product catalog service that is really just a bunch of products. It doesn't really necessarily have any user information, and most often you'd be calling that from another service itself. So it's more of a service-to-service type call where you don't need to have that user information. So there may be other use cases that you have in your particular scenarios at work, but there are those other examples you can refer to for those particular scenarios. But for this case, we're using client credentials and demonstrating that. So we set that grant type explicitly to be client credentials so that it will use that. Okay, so we've got our dependencies, we've got our configuration there. Now, one challenge is now that we're both a client and a resource server, we need to kind of override what Spring Boot would normally do for its auto configuration. So if we go to microservice B and just come in here over to the config, we're going to add in a new config resource server config. Okay, so we're just going to extend web security configure adapter, enable web security. Okay, so what Spring Security would normally give you for a resource server is just like this. I think I zoomed in a little bit too much. All right. There we are. So with the exclusion of this is exactly what, exclusion of this OAuth2 client section, this is exactly what Spring Boot would auto-configure for the resource server. Now, since we're also a client, what it would also do is it would add the OAuth2 client configuration as well as OAuth2 login. But since we're a system service, we don't have any login to perform. We don't want that to happen, so that's why we're having to create a custom configuration here. And we're just wanting to set in the fact that this is an OAuth2 client as well. So we've got that set. now that we are an OAuth2 client and a resource server, let's use our let's set up our web client just like Joe was doing before to use to not just be the base web client, so that it can have access tokens and use the client credentials flow to get the tokens that it needs. All right, web client config. So that's the default one. We're going to go over to this complete one that Joe was showing us before. And just to be really concise, we're going to use the providers that we care about, which is only client credentials. We don't want to use the authorization code flow. We don't want to use refresh token. The reason we don't want to use refresh token is because when you've got client credentials, you just go directly to the token endpoint and get the tokens that you need. You don't need to have any other further dance that's going on. So we've set that that way. So now our web client is configured. Let's now see where our web client is used. So I'm going to close this down here, and we're going to come over here. So we get our call coming in from the UI app to service B. So that's what we have right here. The call's coming into service B, and then when service B gets that call, it's going to go and call service C. Now, normally what Joe had done was show us how to use the handler method argument resolver. We're going to do a different way here. We're going to actually delay sort of creating our authorized, we won't be forcing our OAuth2 authorized client at the beginning of this method, but we'll just drill in here to our call to service C, and we're actually just going to take that registration ID, which is client C, and pass that into our attributes for the web client. So the web client, when it's making its calls, can call the token endpoint if it needs to get an access token in order to call the downstream service. So we're all set up and ready to go here now. So what I'm going to do is restart. We've already restarted microservice C, so we're going to restart microservice B. And what we're expecting is that now we're going to have the last leg of our journey completed, where microservice B is going to be calling microservice C using the client credentials grant. So once again, I'll just close that all down. We'll log in again. And we're going to go to our client credentials section here. There we are. Okay, so I'm just going to make that a bit bigger again so you can see. So as you can see, as Joe was showing, the JOT ID is the same for the first one because it's using the same token. But you can see here the highlighted section here that we're using a different token. It's got a different identifier altogether. It's also got different authorities, and it's also got a different subject. This is the client rather than the user that we have up here in these other subs, because this is a client credentials call. So now we have completely secured the architecture. However, we're not doing any fine-grained authorizations yet. Any validly signed token is coming into these services, and we're allowing those to get through. But we want to make sure that, for example, microservice B authorizes on authority B. So let's add some fine-grained authorization to make sure that we're not letting just anything come through. So the way we're going to do that is we're just going to leverage that resource server config that we had there already. And we're just going to, for microservice B, and we're going to come in here and do this. All right, so we've got an MVC matcher on our service B, and we're adding this other piece where we're authorizing on authority B. Now, why do we have scope underscore authority B? Well, it's because when the resource server receives the JOT, it ends up converting that into granted authorities, and when it's created as a granted authority, it just appends scope underscore at the beginning of your scope name. But what we're going to do now is actually just actually put something different here. We're going to put in like authority X. We know full well that our token does not have authority X in it. And what we want to see is how we're going to, hopefully we're going to be getting a 403 to show that access is denied for that particular call. So I'm going to restart microservice B. All right, and I'm going to hit refresh, and there we go, 403 forbidden. We're not able to actually make that call to service B anymore because we're authorizing on authority X. Now if I switch this back over to authority B, we know that we do have authority B, and I'm just going to restart that again. And there we go. Now we're allowed to go back in and everything's working as it was before, but we're secured and we're authorizing on those particular scopes in the tokens. So yeah, our architecture is now completely secured. We've got our authorization code grant and a client talking to microservice A and B. We have a client credentials client then going on to call microservice C. And yeah. Joe's going to have a few closing remarks.
Yeah, we got time. We got a couple of minutes. We actually hit the time perfectly. Yeah, so the one thing I want to really just kind of go over, and obviously we can't do this. We can't do all of this. There's a couple of flows here: the token relay and token exchange. I want to just talk about those patterns, those interactions, because they're very important, especially the token relay. If you use that wrong. Token relay, I mean, essentially is, let's go to this diagram here. So I could set up client ABC instead of client AB, right? Client ABC on UI app, and ultimately authorize that client with the 3 authorities, so 1 extra authority, so 1 extra level of access privilege, right? And ultimately just relay the tokens to all downstream resource servers. So microservice B would just relay it to microservice C, right? Now this pattern, you got to be very careful with it, especially if you, let's say you got 10 resource servers and you're authorizing 1 client to have access privileges to access all 10 of those resource servers. So imagine what would happen if that authorization or that access token got leaked, right? The malicious user now has access to all 10 of the services, obviously if it's accessible from within the network, right? So you got to be really careful with that. Definitely talk to your InfoSec team if you plan on using the token relay pattern, and it might be a valid pattern to use deep inside the firewall. It's definitely a convenient way of doing things, and hey, it's nice to do things conveniently and keep things simple, but it could be very dangerous too. So be careful with using the token relay. What you could do instead is token exchange, right? So in this case, let's say we have this access token with 3 authorities. Well, let's go back to our original what we demoed is we have client AB. Client AB could call microservice A and B, but it's still got these 2 authorities, right? Authority A and authority B. Now I ultimately want to call microservice C in the tightest secure way possible. Now, the only way to really do that is to pass an access token to microservice C that only has the privileges to access that one service, and that's it. No extra access privileges or authorities. So what you can do in this particular case is set up a client on microservice B to perform a token exchange, right? It receives a token, the resource server receives a token on microservice B, calls a token endpoint with that token, that JWT. At least in this sample, it's performing the JWT bearer grant, right? So it receives a JWT, passes that JWT to the token endpoint with the privileges that it wants to downgrade, right? In this case, would be passing authority C. And then ultimately an access token will come back that looks exactly the same as the one that it received, but with lesser privileges that could only call microservice C. That's a great pattern. That spec is still kind of like in the workings as the token exchange spec. The JWT bearer grant is what was implemented in this sample. So definitely keep an eye on those different grant, like that pattern, token relay, be very careful with that. And token exchange, keep an eye on that for sure. We will definitely implement, provide implementations of the token exchange, authorized client providers as the spec gets more refined and finalized. that's pretty much it. We're at the 1 hour mark, and we got 10 minutes for questions. So we're gonna like open up the audience to questions. Any questions?
Is there a way to confirm that like microservice B is the one that got the actual authorization for group B instead of like microservice A using the microservice B authorization? Can you confirm that like the group that's claiming that they have that backend privilege is actually that group?
Well, okay, I'm going to reiterate the question. I want to make sure I'm going to answer probably, and so everyone else could hear. So microservice B receives an access token, and it has certain authorities. And what you want to be able to do is validate that it actually has those authorities.
So for B to access C,
Yeah.
I want to make sure that C is only allowing access to B, and that whoever wrote microservice A isn't trying to use the B client access.
Okay. Okay, so you just want to make sure when a resource server receives a token that it's the intended audience, right? And that's typically what you would do. The audience field, and this is once again, it's how you configure the provider, right? Because that access token, it could have an audience claim, right? And in this particular case, let's say microservice C. Microservice C, sure, it's authorizing on authority C, but you also want to do an extra validation check, as in this token is only intended for microservice C. So that's the audience field, right? But that comes down to how you configure it on a provider. When the client goes through that flow, you need to configure on the provider to ensure that it sets the audience field with the intended receivers, in this case microservice C. However that's done on the provider, it might be a unique identifier of the resource server or a URI, I'm not really sure, it's provider specific. But that's how you would go about it. Because yeah, there's a lot more that can be done to protect resource servers. You know, we've just showed a simple case, you know, some basic scope-based authorization, right, and valid signatures. Great. In the back there.
Yes, I have two questions. Kind of one is hopefully a very quick follow-up on that. I assume that the Spring Security configuration supports validating the audience.
Well, the question was, is Spring Security validating the audience? We were just actually, that is related. There's an OAuth2 token validator interface, and you could plug that into your configuration, into your JWT configuration. So once again, depending how things are configured on the provider, and when that access token is minted, that audience field, it's going to be a specific format for a resource server. And then in your JWT configuration, you could configure a custom validator that validates the audience field. It's pretty easy to do. Check out the reference manual. The OAuth2 client and resource server support is fully documented. I don't think we missed one feature. So it's there. So check it out. Yeah.
My other question, if that's okay.
Sure.
So you mentioned using the authorized client ID manager to be able to use other HTTP clients, or I might be getting that class name wrong.
I got you, yeah.
So you guys don't have any built-in support for REST template at all?
So the question is, do we have built-in support for REST template? No, we don't. REST template, we're favoring web client going forward. There's a lot of flexibility with web client. There's limitations with REST template, so we're really not building new features into REST template. But with the authorized client manager instance, you get your authorized client, you have access to your access token, you could use REST template easily. All you got to do is add an interceptor with the authorized client, and it just sets the authorization header. It'd be pretty minimal code. But no, there's no direct support with REST template. Any other questions?
Yeah, so for the authorizing server, what is the granularity? For example, in the domain-driven design, right? So you have a domain, right? So each domain actually have a authorizing server, or there is also subdomain, right? So should I have a centralized authorizing server, or have a multiple, like even for each subdomain, right?
So the question is, in a bigger architecture, in a bigger enterprise architecture, do we have one authorization provider or do we have multiple? And how do we group them together? Maybe we got different subnetworks or subdomains, and maybe we want an authorization server per domain. That's really an architecture question. You got to talk to the InfoSec team and your architecture. I can't really answer that without really knowing the application, but that's valid. That could happen. You could have multiple authorization servers, but that, once again, that just comes down how security is set up within your organization. So sorry I couldn't answer that question, but it's definitely, that would be, I'd have to have more context, and it's very organization specific.
Also, for the single page application,
Yeah.
so do I need to have, should I, this single page application, directly calling your authorization server to get authorized land? Or there's the Spring Gateway anyway, right? So
Yeah.
I kind of a little bit confused. What is the really flow? We introduced so many technology, have Spring Gateway, Spring.
So yeah, we get this question a lot regarding single page applications. Do single page applications directly call or perform the authorization grant and go directly to the authorization and token endpoint? Don't ever do that, because the thing is your access token comes back to the browser, right? That could easily get leaked. Single page applications, just session based, right? Typically if you want to set up authentication, OpenID Connect, authentication with a single page app, your entry point should be where the authentication triggers, not your single page app. So maybe your entry point is, the default is OAuth2 / authorization / your client registration. You really want to hit that first, right? So you hit that first, you go through the authentication, and then your redirect URI is where your single page application loads, right? Now it loads, you got the established session, and your access tokens are on the server. Yeah, that's how you would do the SPA. Yeah. Any other questions?
Can you share the link, by the way? Yeah,
Oh, yeah, for sure. Yeah, good call. Yes.
If you add Spring Cloud Gateway in the mix of this, right, the architecture diagram that you were showing, right?
Yeah.
What's going to happen to the token exchange and the token?
Well, that's a good question. I want to get Spring Cloud Gateway as the next step of the evolution of this repo, right? I want to get the gateway. I want to remove the UI app and get Spring Cloud Gateway in there and get that working, right? So keep an eye on this repo. But ultimately, Spring Cloud Gateway would replace the UI app, and it would perform the OpenID authentication, right? And it would also perform that one authorization in that particular case, right? For the client AB, but everything else would remain the same. But I gotta flush that out. But that's something that I want to do next for this repo, and that's probably going to be in my next talk, the integration of Spring Cloud Gateway.
One follow-up on that. So is it going to have the support for the RS architecture?
We're definitely going to talk about that and look at that, and I would bet we will. I just don't know when. Yeah. Any other questions? Back there?
So you are using a Key Cloak for the registration server.
Yeah.
Do you have any option?
Any authorization server. Yeah, like in the client registration, you know how you have that provider section? I could have easily configured 3 different providers and 10 different client registrations, but each of the clients point to the different providers. So you got a lot of flexibility. You don't have to use one specific provider. You could use as many providers as you want and as many client registrations as you want. Just all depends on your specific flow and your application. Sorry? Oh yeah, Key Cloak is easy. It just works, and what I really love about it's got a UI, so I can manage my clients and users. Key Cloak's great. Highly recommend it. Any other questions? Is there anyone else? Because I know if there's no one else, I just want to give an opportunity for someone new. Yes.
So for the client credentials, does it get a token for every call that makes?
No, client credentials. Yeah, in the OAuth2 spec, it's not recommended to have a refresh token come back, right? So what happens instead of refreshing, as in the case of authorization code or resource owner password credentials, if the token is expired, it just renews it. It just literally just calls the token endpoint again, right? So that's what happens, and that's all built in. You don't have to enable refresh token when you're building that builder, because that's not applicable to the client registry grant. It just does it. It checks before it makes the request if the access token expired. If it is, call token endpoint, get another one, then make the request. Yeah. I didn't repeat that question. But yeah, the question was, it's probably late now anyways, but I'll do it anyways. For the client credentials flow, does it refresh? And anyways, I gave the answer, so there you go. One more, what's the time? Do we have, done? Okay, you know what, we're done. But thank you very much for coming out. We're gonna be outside if there's any other questions.
Thanks so much.